After launching on December 25, 2021, the James Webb Space Telescope promises an astronomical revolution. The U.S. Space Agency boasts that it will literally look back in time to see the very first galaxies that formed in the early universe. As if those claims weren't bold enough, scientists have now surmised that the eventual successor to the world-famous and beloved Hubble Space Telescope may, thanks to its 6.5-meter golden mirror and exquisitely sensitive cameras, have another extraordinary talent. Yes, I'm talking about looking for signs of alien life in space. It's been a question puzzling scientists and space lovers for decades, but astronomers now believe that the James Webb Telescope could give us clues whether aliens so exist or not. The James Webb Telescope may be able to look for signs of alien life, detecting whether the atmosphere of planets orbiting nearby stars is being modified by that life. Despite this, the project to build it narrowly survived cancellation by the U.S. government in 2011. That was in no small part down to its astronomical cost, an estimated $10 billion, rather than its originally planned $1 billion. Back on Earth, however, astronomers including the University of Washington team, who proposed life detection observations using the telescope, are unerringly thrilled at the prospect of this launch. Now, a question might arise in your mind: how to detect life on distant planets? That's a good question. We have the answer for you. University of Washington astronomer Joshua Totten and his team have looked into whether the telescope could detect signs of what they call biosignatures in the atmosphere of planets that are orbiting a nearby star. According to Joshua, these life detection observations could be done in the next few years. The basis for this research may lie in JWST, being so sensitive to light that it could pick up so-called atmospheric chemical disequilibrium. It may not be a catchy term, but it is an idea with a long heritage, promoted by celebrated scientists James Lovelock and Carl Sagan. The reasoning is that if all life on Earth disappeared tomorrow, the many gases which make up our atmosphere would undergo natural chemical reactions, and the atmosphere would slowly revert to a different chemical mixture. It is continuously held away from this state by organisms on our planet, expelling waste gases as they live. Because of this, searching for signs of oxygen, or its chemical cousin ozone, has long been thought to be a good way of finding life. But this does rest on the assumption that extraterrestrial life runs by the same biological rules as our own. It might not. Therefore, assessing chemical disequilibrium, looking for other gases, and figuring out how far out of kilter from normal a planet's atmospheres sits could be key to finding alien life of any kind. The chemical makeup of the atmosphere of a planet orbiting another star can be measured in light by carefully measuring the minuscule dip in starlight as the planet passes between us and the star during the planet's orbit. The gases in the planet's atmosphere cause the light reduction to vary with the wavelength of light, revealing information about how much of each chemical is present. Now, where is the best place to look? Totten simulated the data that would be obtained if James Webb Telescope were to look at planets orbiting a small Jupiter-sized star called TRAPPIST-1, about 39.6 light-years away from the Sun. This star caused a sensation in 2017, when it was discovered to host 7 Earth-sized planets, several of which could possess liquid water, and hence might be a good bet for hosting life, maybe aliens. The Washington researcher predicts that James Webb could measure the amounts of methane and carbon dioxide in the atmosphere of the 4th planet, TRAPPIST-1e, from the dips in light at wavelength affected by these gases. It would be a tough measurement of an unimaginably tiny signal, but Cornell University astronomer Prof. Jonathan Leonard, who was not involved in this study, is excited by the prediction, saying they make the case that this can really be done with JWST. If you detect a lot of methane on a rocky planet, you typically need a massive source to explain that. We know biological activity creates large amounts of methane on Earth, because making methane is a fairly easy thing to do metabolically. In other words, biological processes on Earth, including those of the human body, release methane often and easily. Reverse engineer that, and finding methane somewhere on a rocky planet in the universe means a life form, maybe even like us, could have made it. But remember, the team's goal is to remove any doubts or false positives while Webb scans for such life forms. Once the measurement is made, Chris Hansen explains, you can then ask the question, do we know of any non-biological processes that could produce that effect? Planetary atmospheres, including our own, he points out, can also be modified by non-biological processes, such as volcanic activity. So, if the atmosphere of TRAPPIST-1e was found to be awry, researchers would then need to rule out any non-biological effects before declaring the existence of extraterrestrial life. Chris Ensign says that kind of confirmation is going to require multiple observations to really make a totally solid case. But if we detect something that we don't have an alternative explanation for, I think that would be an incredibly exciting discovery. So after analyzing what might set non-biological methane apart from biological methane, the researchers came up with a solid rule of thumb for when Webb finally detects the telling molecule on a rocky planet, orbiting a sun-like star and in the habitable zone. They say that if the planet's atmosphere has a lot of carbon dioxide in addition to the methane, and has much more methane than carbon monoxide, and if the orb doesn't seem to have an extremely water-rich composition, we might be in the clear to rule out false positives. If any or all of these things don't ring true, they could have come from a non-biological source. Who else will be doing this? For now, the telescope's golden mirror remains securely locked in a lab in California, and astronomers must continue to wait for these possibilities to be explored. The James Webb Telescope will be joining a host of new facilities that will subject planets around other stars to some serious scrutiny over the next few decades. Huge ground-based telescopes in Hawaii and Chile are also planned, and the European Space Agency's UK-led aerial mission, designed to probe the atmospheres of planets around other stars, will blast off in the late 2020s. Prof. Leonine says, "I think that we are in a remarkable time for understanding our universe and explaining the cosmos, and James Webb is going to take the next step in that. It is going to be truly worth it." Prof. Gillian Wright, the principal scientist on the telescope's UK-led mid-infrared instrument, agrees. "We have never had access to something this big in space before." He says, "To say a telescope will open up new windows on the universe sounds kind of clinched, but with James Webb, it's really true." And with that, here's the end of the video. Whether James Webb would be able to find clear evidence of alien life in space, only time will tell, but scientists are pretty hopeful. For more interesting videos, make sure to subscribe to our channel and also press that notification icon. See you at the next one. Goodbye.